So I'm just going to chat about kind of how we built different parts of the unit circle. And so here, this is where we started. And this began as an equilateral triangle. And from that, we created a right triangle by folding that in half. Same thing on this one. We started with a square and we folded that in half into a right triangle. And so we have two different types of right triangles, and using Pythagorean theorem and knowing that the two hypotenuse lengths are both 1 for either triangle, I gave them that. So the hypotenuse lengths are both 1. And so if we know this is 1, we know that this is x squared plus x squared, because those distances are the same, is equal to 1 squared. And then we go through and solve that, and we end up with 1 over square root of 2, rationalize it, and we end up with square root of 2 over 2 and square root of 2 over 2. So that's your 45, 45, 90 triangle. And we know it's 45, 45, 90 because the two side lengths are the same, because it began as a square. And this one we know is the 30, 60, 90 triangle because it began as an equilateral triangle. And so if we know this one is 1, we know all the other side lengths were 1 for that equilateral triangle. And if we folded it in half, it ended up being 1/2. And then we could use Pythagorean theorem for this one, and we ended up with the square root of 3/4, which turns into the square root of 3 over 2. And so that's where our two triangles came from. And then we used those two triangles. Then we drew all the triangles. And so the stipulations for the triangles was that a leg of the triangle had to be on the x-axis, and the hypotenuse had to connect with the origin. And so in each of the quadrants, we have the 30, 60, 90 triangle twice in two different orientations, and then my 45, 45, 90 triangle is the green one. And so we drew out all of those triangles. That took a little bit. And then the next thing I had everyone do was to draw in the angle measures. The angle measures I gave them to start with was 0, 90, 180, 270, and 360. And so all of the angle measures in between 0 and 90 had to be between 0 and 90. In quadrant 2 had to be between 90 and 180. And quadrant 3 had to be between 180 and 270, and then in quadrant 4, 270 and 360. And so 30, 45, 60, 90, and then this angle measures 30, so 30 past 90, and then 135, 150. And so all the pink triangles have a reference angle here in the middle of 30. And the green ones all have a reference angle of 45, and all the blue ones have a reference angle of 60. And so we went all the way around the circle, labeling all of the angle measures. And then the next thing that we did was we talked about radians. And so radians, you might remember, come from, or where you have talked about it in the past, is in geometry. When you were changing from radians to degrees in the calculator, you always had to change that mode. And so now we're actually learning about like what is a radian and where does that come from. And so I had the students take their triangles and run their triangle along the outside of their circle. And so it ended up being all the way around the circle, ended up being about 6 radius lengths around the outside, a little bit more than that. And so then I was like, okay, what is it halfway around the circle? And they were like, well, it's a little bit more than 3. And I was like, okay, what is a number that's a little bit more than 3 that you've heard before? And they told me pi, which is exactly right. So halfway around my circle has a radian angle measure of pi, and then all the way around has a radian angle of 2 pi. And so where 1 radian comes from is 1 radius length is 1 radian, and 2 radius lengths would be 2 radians, and 3 radius lengths on the outside would give me 3 radians. Halfway around would give me pi radians. And then we have 4 radians and 5 radians and 6 radians. And then 2 pi would get me all the way around. And so that's where the radian comes from, is the radius length. And that angle doesn't change no matter the size, because your proportion of your radius to the circumference is the same every single time. So that gave me radians. And then we went around and talked about the radian angle measures for each of these specific angles. And so where that came from, or what helped us kind of identify that, was talking first about pi over 2. So if this is halfway around my circle, and that's pi, 90 and 180, because 180 and pi are the same, 90 is halfway to 180, and so that would also mean that it is 1/2 pi, or pi over 2. And so if this is pi over 2, and this is pi over 2, so that would be 2 pi over 2, giving me 1 whole pi. Another one around, or pi plus pi over 2, gives me 3 pi over 2, and then all the way around would give me 4 pi over 2, or 2 pi. And so that's what we said. So here we have 0 pi, pi over 2, pi, 3 pi over 2, and then 2 pi. And then we could talk about the green one. And so if we take those pieces and we break those in half again, we end up with pi over 4. And so we are breaking pi into 4 pieces. So this is pi over 4, 2 pi over 4, or pi over 2, 3 pi over 4, and 4 pi over 4. And so that's where these come from. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then we can talk about the pink and the blue. And so here, if we break it into 6 pieces, because 30 degrees, when you think about 180, if you take 180 and divide it into 6 equal pieces, then that is pi over 6, because we've broken pi into 6 pieces. So we have 1 pi over 6, that's 30 degrees. Well, 30 degrees plus another 30 degrees gives me 60 degrees, which is the other angle measure. And so that would be 2 pi over 6, or pi over 3. And so coming back over here, this is pi over 6, and then pi over 3. And so then if we add another to 3 pi over 6 would give me pi over 2. 4 pi over 6, or 2 pi over 3, gives me this blue line. And then 5 pi over 6 gives me the pink line, and 6 pi over 6 is the whole. 7 pi over 6 gives me the next pink line. 8 pi over 6 is really 4 pi over 3 when you simplify. 9 pi over 6 simplifies to 3/2. 10 pi over 6 is 5/3 pi. 11 pi over 6, and then 12 pi over 6 to get all the way around. And so it's really just a bunch of pi pieces that you're really counting. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So we're starting here and going all the way around. And so that's our radian angle measures. And then last but not least, we have our coordinates. And so these coordinates come from the very beginning when we were talking about these side lengths of our triangles. The side lengths of our triangles end up being the locations in space to get us all the way around my unit circle. And why it's a circle is because we already decided that these hypotenuse lengths were the same. And so if those hypotenuse lengths are the same, it's really my radius length. And so here, the blue and the pink triangles are the same, but the x's and y's have switched. So this ended up being 1/2, and then up square root 3 over 2. On the pink one, it's square root 3 over 2, up 1/2. And my 45, 45, 90 triangle is the same, and so that's why my x and y values are the same. This one is 1, 0, 0, 1, negative 1, 0, 0, negative 1, because the radius still has to be 1, and when we cross those, it's those axes, it's just got a distance of 1. And so last but not least, I had the students reflect over the x-axis and the y-axis to get all of the other values in their correct locations. So hopefully this helps you in your understanding of the unit circle and where these values came from.